Hi everyone, this is the last video of the unit, video 2-21 for the weekend of Friday, October 28th. The only homework is page 30, number 5, just one problem. And guys, I've decided just now to change this video lesson a little bit. I was going to show you two methods for each of these examples. Instead, I'm just going to stick with the method that we actually have already encountered in class. This is, at the beginning, I titled this, or the topic of this video, double chain rule, but it could be triple chain rule or quadruple chain rule. So chain rules whenever you have one function inside of another and you're taking the derivative. So taking the derivative of a composition of functions. But as you see with the first example, it's not just one function inside of another, it's one function inside of another, which is then again inside of another. So in this situation, guys, figure out how many functions are involved. Okay, so in this case, I've got 3 functions involved, and if you don't see it, I'll be more specific in a moment. So I look here and I see x to the third is what I would consider the innermost function. That is inside of cosine, and then cosine is inside of the squaring function here, blank to the second. Okay, the parentheses raised to the second power. So I'm going to have 3 columns to my chart that I like to use for the chain rule. So this is going to be an in and out chart. And I'll just put the innermost function here, x to the third. That is inside of cosine of blank. And that is inside of blank to the second. Okay? So the derivative of this function, the first one, is 3x to the second times. Derivative of cosine is negative sine of blank, and then what goes back in, x to the third, times the derivative of blank squared is 2 blank to the first. Okay, that's power rule there. And then the stuff that was in there before has to go back in. So cosine goes back in, and x to the third goes back in inside of that. I know, guys, that we've already been doing these types of derivatives in class, but I'm just putting this video in because just in case it's unclear to you or you're a little bit shaky on it, maybe this will help. Okay, so f prime of x equals, I'm just going to clean it up a little bit. I've got, what, negative 6x squared sine x to the third cosine x to the third. Okay, now the next one will be more complicated than anything we've done so far. Okay, so first, guys, whenever you have a trig function raised to a power like this, like tangent cubed of this stuff, I would rewrite it like this. Tangent of radical cotangent 7x to the third. Okay, anytime you have a trig function raised to a power, I would rewrite it like that. The first one was already written that way for us, with the squared on the outside. Okay, so I do this because it's easier to see what's inside of what. All right, so I have got 7x. All right, so let me try this. Okay, so I have got 7x. That is inside of cotangent of blank. That is inside of the radical, so I'll say blank to the 1/2. That is inside of tangent. I'm not doing the second method, guys, so I'll just run over here. That is inside of tangent, and tangent is inside of blank to the third. Now, when I started talking, I wasn't sure how many columns I'd have. That's why I didn't do the columns first. So there's that. So you don't even have to do these i's, but so these are all the functions. So I've got 4 functions all inside of blank to the third. Okay, guys, so now I'm going to take the derivatives of all of them and then put the stuff that was inside to begin with back in. So the derivative of 7x is 7. Okay, 7. The derivative of cotangent, this is one to be memorized, and it is negative cosecant squared of blank. And 7x goes back in the blank. Derivative of blank to the 1/2, I'm using power rule, so this is 1/2 blank to the negative 1/2. Okay, and back in the blank goes cotangent 7x. Derivative of tangent is secant squared of blank. Back in the blank goes all that other stuff. I'm going to convert at this point back to radical notation for this one, so I don't have so many parentheses inside of parentheses. So radical cotangent of 7x. And then finally, blank to the 3rd, power rule here, 3 blank to the 2nd, and everything's got to go back in. So tangent, tangent radical cotangent 7x. Okay, now I'll just state my final answer a little bit more clear. And guys, you don't even have to simplify the way that I'm about to, but I already did this earlier. So let me write down, and you please write down as well, what I ended up with. And then as a last exercise, there's only one little problem for homework, and this is a short video. So, before you move on to the homework, make sure you're comfortable with how I got this answer. Okay, not that we need to simplify, but I'm sure when you're in college you'll have to, so, yeah. So cosecant squared of 7x, secant squared of 7x, no, secant squared of, secant squared of, darn it, radical cotangent 7x, sorry. That's all inside of secant squared. And tangent squared. Tangent squared of radical cotangent 7x. Okay, the whole thing over 2 radical cotangent 7x. Okay, so as a last little exercise, guys, before your homework, just make sure you understand how I ended up with that. And by all means, tell me tomorrow if I made any sort of mistake. Okay, I'll see you soon. Bye-bye.